Good afternoon. I will start with a brief introduction about myself. My name is Nicolás Cortegoso Vissio. I'm like a PhD student of mathematical linguistics in St. Petersburg State University. And today our topic is how computers identify language and write and text. About this presentation, first we are going just like to trace a parallelism between like human intuition and how could we implement this intuition in computers. And then after the discussion, I will try to show you a working example. And then we are going to draw some conclusions about this topic. What we understand when we talk about like a language classifier for computers, how should it work? A language classifier should be able to get as input a word, a sentence, or like a fragment of text fragment, process it and give us like as output the text of the language. This is the main idea that we are what we want to achieve. First, like we are going to discuss like some like intuitions that how could we build something like that. So the first things that comes to mind is like alphabet. We know that there are some languages that have like a specific alphabet. So in principle, we could just like as we humans, for example, like recognize that text is like in Korean or in Georgian, Armenian, the language that they have like their own alphabets. We could just like specify the encoding so the computer could understand that it's like a text in one of those languages. Well, here I see that it was a problem just with the encoding. Trust me, it should be here a text in Korean, in Georgian, in Armenian. But okay, during the the conversion to PDF, something failed. What about this approach? This approach would like work fine if we, for example, are trying to differentiate a Korean text from non-Korean text, or Georgian text from a Russian text. But the problem is like most of the language of the world, they are share a script. It could be like a Latin script, a Cyrillic. So this method would not take us very, very far. So what about special symbols? In the language, they share a script. There are some scripts that have like some characteristic symbols that we could use potentially to identify them. For instance, if we get Spanish, we got the letter ñ. For example, it's really characteristic of Spanish, and most of the languages do not have it. So if we find a text that has that letter, well, we could like most probably it's going to be like a text in Spanish. So with this in mind, we could like build like some algorithm. For example, like decision tree, like is depicted here on the slide, that based on rules that has that symbol or does not have a like special symbol, just like determine like the language of the text or the word. This would work fine, but it had some problems. For example, if we get like a fair amount of quantity of text, we are most likely to find like those special symbols. But if we have like an isolated word, without special symbols, we are not able, this is not going to work. For example, we got the word, I know, internet, for example, no special symbols, what language would be? And also this method could be fooled easily if we have something like here in the example, like the English alphabet does not include the letter Ñ, for example. It would be the classifier would say that it's like a Spanish text because it finds that special symbols, but it's not. And another difficulty would be that for every single language that we decide to include in the classifier, we need to rewrite the rules, rewrite the algorithm, which would be like cumbersome. So we could do it better. And we have the dictionary approach. We can define a language like a collection of words. That's most likely when you get like in a dictionary, for example, we say, okay, it's a dictionary of English because it contains like English words. It's a French dictionary because it's like contains French words. So potentially we could use like a dictionary for every language that we want to identify. The problem here, the main one is like that we need a huge amount of data. We need a dictionary for each language. That is a lot. And even if the dictionaries are big, they are always going to be like words outside the lexicon. So that's the main problem. And also secondary problem, we could say that it's difficult to implement with high inflected languages. If we take, for example, for instance, English, that's not highly inflected, has like more like, say, simple morphology. It would be easier than to implement that for, I don't know, for Russian, for example. They had like a lot of declensions and conjugations and so on. So definitely, this method is not going to be a very good idea. But we know that there are different types of words in a language, and most of languages has like certain words that repeats a lot. They come, we will, how you say, find them in text very often. Most of the time they are like the so-called function words, like prepositions, pronouns, conjunctions, and particles. And so potentially we could define like a small dictionary for every language that contains only this type of words. And then when you get a piece of text or a sentence, or just like check it if the text contains that words, just like to determine the language. This certainly is going to work better than the dictionary, the whole dictionary approach, but still it has a problem. That is, it's going to work only with texts. If you have like an isolated word, it wouldn't, if it's not a preposition or a pronoun, it's going to fail. So still we can do it better. And what about us? Like we have like a human intuition that I'm a native speaker of Spanish. So when I see, for example, this picture, I see that word, I could understand that it's not a Spanish word. It could be like different language. It depends if of the exposure that we have to different languages. We say, okay, this is Polish, but still we have the intuition that it's not likely to be a Spanish word. The same with the second word here. It does not seem to be a Spanish word. Different situation is here in the example, that's la boca de la coca. Even that is like it's nonsense. I could recognize that it sounds like Spanish. Maybe, I don't know, a Latin language has something that tell us that could be. And we can, how we just like got that intuition. The first thing that we could say, okay, that for example, in Spanish, it's not very likely to see a lot of W's, for example. They're like letters that are kind of like alien to Spanish. And also there are like some cluster of consonants here, for example, Lebenversicherung, that also are not found in every language. So we can say that if we consider like the frequency of some letters and or consonant cluster sequences, we could have an intuition that about what language it is. And this is the idea is it's not new. And the study of letter distribution in language has been for a long time. And some of the works that are more, how you say, known about this are, for example, the work from Andrei Markov, and also a little later from Claude Shannon, who basically they study like the distribution of letter in texts. How is the frequency that a letter could be found in a certain text, and in what sequence with the letters follows, what letters precedes that, and so on. So a way that we have in linguistics to model this kind of sequence of letters is called like it's called Engram model. An Engram model is basically a conditional probability of seeing a letter, observing a letter, given that we have seen like some previous letters before. It's basically the probability of a sequence. There are different types of engrams. They're called, for example, a bigram is when we take into account just the previous letter to tell the probability of one character. And a trigram, it is when we take into account the two previous letters. And so on. Then you get fourgrams that are really rarely used, but most of the time we're going to work with trigrams, which is like the probability of seeing a letter given we observed already two letters. To put an example, for example, in English, that is a very, very, I think maybe it's the most common word in English is the article the. So in English, we will have a high probability of observing e after the. So that's how we can model a language using like an engram model, like a sequence of letters. How we train this kind of models? Well, typically they are trained in texts, of course. So if we want to train like an engram model for English, we need to have a collection of English texts, and we want to train for Italian, we need like a collection of Italian texts and so on. And but basically, when I speak about texts, we can just use many sources. Then I'm going to show an example. And here in the slide, we see like an example that how it looks. This is, for example, the probability of encountering the letter M after letter R and O. This is the probability for Spanish, for example, and we see that this has a different probability for Italian. This is, for example, this is a symbol to say the very, very start of the sentence. So this is the probability that a word in Spanish starts with the letter R, and this is the probability for Italian, for example, to start with the letter R. This is the probability that I obtained for training these language models on my collection of texts. It does not mean that it's the how to say absolute probability of for those languages. And here in the last one, for example, it is the probability of having these letters N and A at the end of the word. The numeral that it is like symbolize the end of a word. So again, different probabilities for Spanish and for Italian. So how we use these probabilities that we have like modelized here to actually use it in a classifier, how it works. Well, first, if we say, for example, we have an input word, could be like, for example, this in the example, amor. We need just like to divide, to split that word also in trigrams. If we are training like say like it was like I did not say, I forgot to say that it was this as a trigram model. It's a trigram model because it takes into account the two previous letters. So if we want to train to use the classifier for trigram models, we need just like to split a word in trigrams, in three sequence of 3 letters. Then for each sequence of 3 letters, we get from the models the probabilities that they have. For example, here's the Spanish, and here we got Italian. So for each sequence of 3 letters, we got the probabilities, and we multiplied the probabilities, and we got like an overall score. And to choose, to decide which language has it is that letter, just to predict the language of the word, we just like pick up the score with the highest the highest score. In this case, for example, the highest score has it's for the word for the Spanish word. I think it would be better just like to show an example. I'm going to try to share my screen. So I don't know if you are seeing my screen right now. I'm going to check in the chat. So yes, of course. So thank you very much. So I'd said before that typically these classifiers are trained like in a collection of texts, but we can train it like to different type of data. For this example, I'm going to use some data sets that we have from this internet site that are basically a list of different cities in the world. So for this example, we are going like to train a classifier that should be able to differentiate between Spanish, Italian, and German languages. So for Spanish, we have like a collection of Spanish cities. For Italian, we have here the same for Italian cities. We would like typically to have like Italian names here. It's not the case everywhere. You see like Rome, for example, is the English name for Roma. That's not like optimal. The same for Naples, for example. But still, then the rest of the data set, I think, is mostly fine. We got like some words that they have like the Italian form. And we're going to have the same for the German cities. Again, some anomalies here that we have, like, for example, Cologne here is like the English name for the city would like to have the German name, but it does not matter. Same for Munich, should be München, but still it would work because we had like then we got like some like German words. Here, this is not important. We are going to look at fast data processing. To obtain this, we obtain a word and a label. The label signifies the language. For example, Madrid, Spanish. We got Rothenburg, German. We got for Spanish, we got ES. From for Italian, we are going to get to have IT. For German, we're going to have DE. So that is called the data set. That's the source that we are going to use to train the model. As I already said, a word and a label. It is also going to train the classifier here. Train the classifier. What I mean when I say train the classifier is we are just like using this data set to extract the probabilities for each combination of 3 words. And when it's already trained, we can see the different trigrams that we obtain. For example, the trigrams that we obtain for Italian. And we get a huge list of different like trigrams, that the combination of letters that we can use to characterize Italian language. If we can see the same collection for German, but the probabilities are going to be different because, of course, German has a different distribution, and the same for Spanish. And for example, we can check the probability for this trigram here. In Spanish, we have a very, very, very tiny probability. But if we check the same for German, for example, we are going to get like a fairly, how you say, higher probability, because it depends. Each language has its own distribution of letters and combinations and sequence of letters. So say that this like already trained, so we can use it right now. And we can use, for example, to predict words. Have that word Deutsch, which is certainly German, and we got here the calculation for each language, and here it is chosen German because it's the one who has the highest probability. If we try this one, Italiano, it's like going to be Italian because Italian again is the highest probability for that sequence of letters. In the beginning, we spoke about like not only words, which like have like sentences or fragment of a text fragment or whatever. So let's try something different. Vamos a la playa. That should be classified as Spanish, and okay, it worked. Spanish again is the highest probability, or something different. It should be German. I don't know. Some cliché. Italian. So it's fairly working. But what happens, for example, if we try to classify something that's not in the classifier does not know, a language that has not been seen before. Let's go, for example, of this like Wikipedia in French. So we're going to get like some text in French. I will going to try inside the classifier what the classifier tell us about this. The classifier say that this is Spanish. So, well, the classifier has not seen French language, so we think that it's like this could be most probably French. Of course, it's not French, but that's what our classifier thinks right now. Of course, we can train it, the classifier, with more like for more languages. Here I have like an example that it has also it has Spanish, Italian, German, but also I just like add French and Polish. So if we paste the same text here, if we are lucky, we are going to get French as a result. Yeah, and we got French. What if we try to get some, I don't know if we have like here some Polish. Yeah, we have it. So we get like since combination, whatever. Paste here. And again, the classifier says PL, that is the label for Polish. So that is basically how would work a classifier for computers, like based on like in sequence of probabilistic sequence of letters. And it's like a kind of it's a data-driven approach, because as we see, we're not writing rules to specify the language like we started this like presentations. We just like adding data, and from the data the classifier learns a language. It pretty works like we humans do. We could decide, for example, like yes, a language is, we recognize a language because we were exposed to the language before, and if we do not have exposure to that language, so we are not going to be able just like to tell which language we have in front of us. So after the demonstration, we get to the conclusions. And so I think that the first the main conclusion that we have from this is like from letter distributions, they could serve us like to identify language. It's a very robust method that we can use to build a device for computers, like to be able to classify language. And as I said before, with this method, we just like are kind of emulating the way that we humans learn. So engrams are like widely used also, like it's like a method that's used in machine learning, which is like basically yes, a way like of learning from data. And also we have seen that for this task of classifying language, we don't need like a huge amount of data. We have trained the model with just like a list of cities. Imagine that it's like, I don't remember how many cities were in for each country, but I highly doubt there are more than how you say 10,000 cities in Italy or in that data set, for example. So we don't need like a huge quantity of data. And of course, we should be really careful about the data that we use to train the models, because for this matter, that use like, for example, if we want to train a model for English, what would we use? Just like following that idea of like using like cities. The model would be different if we use, for example, to train it from cities from the United States and from city from Great Britain. For example, if we take just, for example, state of California to train the model. In California, you know, there's a lot of cities that have Spanish names, so most likely we're going to have like an hybrid English-Spanish model, and not like how you say, a suitable model for English language. So this is more related to the data engineering, and so the most important thing is like the quality of the data set, of the training data that we use to train the models. It's the most important thing that we should take into consideration. But that's how it works. So if you like to check the code that you have seen on screen, please, you're welcome to use it. You can just get the code from this repository. So you can retrain the model just to use with different languages, and there you get the instructions, how it works, how it should be trained. And so that's all. So I would be happy to answer your questions. I'm going to look in the chat if there's something. Aha, I see the first one from Olga Alexandrovna. Thanks for your talk. What do you think if your approach sensitive to the dialectal differences in written texts? Thank you very much for the questions. Yeah, of course. Even we would be able to train it for different dialects. For example, let's consider the case of Italy, a country with a lot of dialects. We could, for example, using the data set that we already used here. It's a hypothesis, because I'm not very familiar about the names of the city, but imagine that, let's assume that in the regions in Naples, for example, I don't know if let's say there's a province of Naples. I know that's a Napolitan language. So maybe the cities that are around Naples, they have like some Napolitan names, and cities on the north of Italy would have like different different names that correspond to the dialects. So we could train, like, for example, the model to distinguish between would be like a Napolitan dialect, and I don't know, something like different dialect of Italy, for example, Piemontese. Yeah, for name an example. I think that could be. No, it's possible. Now we need just like to check the data that we are using to train the model. So of course, yes, it's really sensitive to dialects. And Karelian PEPs, I'm not familiar what is PEPs. Is that it's a dialect? So close languages. So okay, so well, if we had like access to a text that we could consider, for example, or a data set, or a text that we consider that is like a good example of Karelian, and we got another text again or data set that we could think that's a good example for bets, you think it's possible? Yes, yes. Of course, if we are going to try to train that model using, for example, like Russian cities, no, it's not going to work. Oh, it's like, okay, yes, there is a corpus. So, if it's another question. Oh, no, it's like as many as you like. There's like a no limitation, I think, about this. You need just like proportionate the model, just like data that has as many languages as you would like to recognize. Here, just like the model was trained with 3 labels, like Spanish, Italian, and German. But there is no limitation. You can add like more data with different labels. For example, we could just like add like English label and add like, for example, a couple of English words. Add like like Chinese label and add like a couple of Chinese words. It does not matter. It should work the same. So it's no limitation about this. And also you can mix. It's not limited to like the examples that we've seen here today are language with a Latin alphabet, but you could use like a Cyrillic alphabet as well. It's no limitations. And in the future, well, nodes as I think, and as I said, like you can go, for example, to a repository, download the model, and follow the instructions, just like or to train it for different languages, as many as you like. If you would like to use it for I don't know, to like specific purpose, just please feel free to contact me. I would like I'm happy to help. So it depends of the data we are going to feed to the model. So no limitation about this point. What is the role of the Jupyter platform? Oh, no, Jupyter is just to show here. I think I'm going to. It's like how you say, comfortable to show in a presentation, but you can implement it. It's important question that, of course. Oh, sorry, I forget to mention that the code is written in Python language. So of course, it's also the algorithm is not like it's not difficult to adapt to another language. But I work as a Python programmer, so I write everything in Python, but could be implemented in another language. And about Jupyter Notebook, I don't know. It's nice. It's a good platform, just like to show some code, show the output of the code, and to write some annotation screen that I think is it's a good way to use a good like tool to use in presentations. But of course, you can use it like just directly on Python. Rule-based element, in which way they can be useful. Yes. You can, yes. You use like a, this model is like a, how do you say, purely statistical, like, but of course you can use like rules before and after that model. For instance, we said would be a rule. Now I cannot think in an example that would be useful to use a rule. If you had something in mind, you can comment and we can discuss it. But yes, so rules could be applied after that output or before, just like using the algorithm and like some kind of filter, I think. How is that implemented right now? It's just like purely statistical. So no rules involved. So look, it's like another one. Is there an other question? What I could comment like about this is like if you want to implement this, it's simple. So it is shown here in the notebook. The once the model is pre-trained, you just like need like you have like literally three commands that you write, and then you can use it to predict the words. Like so there is no need to have like how do you say, like no programming experience, just like to use it for a project, just like a Python installed in the computer. So I don't see new questions. So I hope that more or less I have answered to your questions. So if you have like commentaries, or you want like to know details about this or whatever, just you got my email there on screen. And as I said, I would be very happy to help. And also, if you want just like to use in your project, please, you're free to download it, use it, modify it, whatever. And also, if you have some technical questions, also I'm here to answer and to help by the implementation. So, and I thank you very much for your attention, and until the next time.